In this video, we are going to take a look at Unit 7, Lesson 1. And that's going to be about lines, angles, and curves, and defining some line segments and angles related to circles. By the end of this lesson, you'll hopefully be able to do a few things. Draw a chord that is not a diameter. So given this circle, being able to draw a chord that is not a diameter. Being able to draw and estimate the measure of an arc, and also be able to draw and estimate the measure of a central angle. So in this first activity, it starts on page 142, just a notice and wonder about these three pictures. So we've got a window here, a wagon wheel, and a bicycle. So go ahead, what are some things that you notice? And what are some things that you wonder? Write down a few things. So you certainly could have noticed and wondered quite a few things about this. Here's some that you might have noticed. You might have noticed that all three objects are circular. The wagon wheel appears to have all radii, so all of these appear to be going into the center. The window has some lines that appear to be diameters and some that are not. The bike wheel doesn't appear to have any diameter or radii. They seem to just kind of go past the center there or not into it. And the spokes on the bike appear to be parallel. Could have come up with other things. That's just a few. Some things you might have wondered about. Is the spoke on the wagon wheel that looks vertical? Okay, so the one that looks like it could be vertical. Let me get something here. Okay, so is this one that looks vertical, is it perpendicular to the ground? So is this going to give you a 90-degree angle here? And then you could have also wondered, maybe are there other names for segments in circles than radius and diameter? And is the area of each wedge of the wagon wheel, so each of these wedges here, are the areas the same? I'll just highlight a few of those in there, but are those little wedges equal in area? So just a few things, could have certainly come up with others. Activity 1.2, so you're going to end up writing your own definitions. Obviously, if you're doing this at home, you'll be doing it by yourself, but we're going to, you should work on writing your own definitions. They are on page 143 to 145. You're going to see some different examples and non-examples. So on page 143, you're going to be working on chords and writing a definition of chords. So look at the chords and the not chords. Page 144, you're going to be trying to do the definition of arcs. So you have some arcs and not arcs. And then on page 145, you're going to be working on a definition for central angles. So here's some central angles. Here's some not central angles. So go ahead, analyze those examples and non-examples to write your own definition, and then come back to the video. Okay, so when you're looking at chords, hopefully you noticed a couple of different things that make these examples and non-examples stand out from each other. So let's highlight a few things on here. All right, so for chords, we see like this one's outside of the circle, okay? This one seems to go outside of the circle as well. You can have shorter chords, but this one just goes to the center. This one doesn't go to the center. So a couple defining characteristics of chords is that they go from side to side, okay? So this endpoint is on the circle, so is this one. This endpoint is on the circle, so is this one. Versus this one has its endpoint in the middle. This one is outside like we talked about, and these endpoints are outside. So for our definition of chord, you should have something similar to this. So a chord is a segment whose endpoints are on a circle. Okay, could have said something like that. Maybe you said a chord starts and stops on the circle. Okay, could have said something like that. All right, let me take this with me. All right, so when we're looking at the arcs, let me just get this started. So for arcs, what are some things that we're noticing? Okay, so obviously we've got some curves here, but there's a curve here as well. And this one is not curved. Okay, so what makes an arc an arc? So an arc appears to be a portion of the circle. Okay, so an arc is a portion of the, you could say edge of the circle. Formed by two endpoints or something similar to that. But it's got a starting, stop, and an ending point, and it's the portion of the circle between those. Okay, so portion of a circle formed by two endpoints, or portion of the circle, of the edge of the circle between. So if you wanted to say between two endpoints, say something like that. Again, it's your definition. It does not have to equal this one exactly. All right, then we've got central angle. So what are we noticing about a central angle? So we obviously have all sorts of angles here, but what's the difference between them? So these ones are all, this is on the edge, this is in the middle of the circle somewhere, this is on the outside. All of these central angles have their vertex at the middle. Okay, or they're also, you could also look at it as being formed by two radii. So each of the rays are two radii. So depending on how you want to write that, but you could say a central angle is an angle whose vertex is at the circle, at the center of the circle. You could also say formed by two radii. That's something similar to that. All right, so looking at comparing and contrasting some of the differences or some of the things about chords, diameters, and radii. So chords, diameters, and radii are all segments. Okay, so some comparisons is that they're all segments. Chords and diameters both go edge to edge. Okay, but the diameter specifically, a diameter has to go through the center. Versus a chord doesn't. So a chord just goes edge to edge, but it doesn't have to go through the center. So a diameter is a chord, but it goes through the center. And then a radius is not a chord. Okay, a radius starts at the center. It's a segment. It goes center to edge. So if we did a picture here, okay, let's mark up the center. You'd have a radius has to go from center to edge. Okay, so it's kind of like almost like it's half a diameter, obviously, but it goes center to edge. And then a diameter would be a chord, but it goes through that center. So it has to go through the center. So we see edge to edge through the center. And then a chord just has to go edge to edge. Okay, so endpoints on the edge doesn't have to go through the center. And then would we consider a complete circle to be an arc? Okay, would we consider a complete circle to be an arc? So yes, it's a portion of a circle. It's just the whole circle. Okay, so it goes from here all the way around to here. That would be an arc. It's just a whole circle. What kinds of segments make up the central angle? So if we look at a central angle again, remember, and we talked about this a little on the last screen, but if you have a central angle and it's formed at the center, okay, these two pieces right here are radii. Draw a circle and draw 2 points on the circle. How many arcs can be defined? So if we draw a circle here, here's 1 point, here's another point. So how many arcs do we have? Well, we've got this one. And then we've also got this one. So 2 different arcs. And remember that the total of a circle is 360 degrees. So if we put those together all the way around, it would be 360. All right, then let's take a look at this diagram and talk about, so you can, if you're doing this at home by yourself, think about how would you find the values of X, Y, and Z. We don't necessarily need to find them, but how would you? So remember that when we have a central angle, that's cutting the arc proportionally all the way out to the edge of the circle. Okay, so this will proportionally, that definition of an angle, okay, would be 60 degrees here. So this X arc is going to be 60 degrees. Okay, a diameter cuts the circle in half. So we know that this whole angle here is 180 degrees. So we could subtract 60 to get the other portion of it. Okay, so we know that this is going to be 60. This is going to be 180 minus 160. And then this arc over here from edge to edge of the diameter, that's going to be a 180 degree arc, or half the circle. All right, then let's take a look on page 146. So this one says draw the central angles in for each arc. So we see these arcs, and then just draw the central angle associated. So from the end point into the middle. So there's the central angle for the blue arc, and then here's the central angle for this orange arc. What does it look like the relationship is, or the size of these angles is? So hopefully when we're looking at it, it looks like they're pretty much the same size. So could we prove that they're the same size? So if we could prove that these two triangles were equal, then that would prove to us that this angle is the same as this angle. So we can look at the fact that these central angles are formed by radii. So this is a radius, and this is a radius, this is a radius, and this is a radius. And so we know all of those segments are equal to each other. So then the two triangles are congruent. So the triangles are congruent by side, side, side. Now that's obviously not a formal proof. We just talked through it, but we can see that we'd get all three sides the same, and then that would make those central angles the same since they're corresponding parts. So now we would know that this angle is congruent to this angle. So then what would that tell us about these arcs? Well, what we just talked about on the other screen, if the central angle proportions out to the arc, if these two angles are equal, then the two arcs must be equal. Okay, so the two arcs are equal in measure. So whatever these angles are, that's how big the measure of the arcs are as well. So what do we notice in this diagram? So in this one, they're giving us these angles as being equal, right? So this time we're getting this central angle. This central angle is equal to this central angle. Okay, so what would we be looking at here? So on the last one, they gave us these chords. This time, they're giving us the central angle. So if we go ahead and kind of highlight this central angle here, we know that these two segments are equal to each other because they're radii. We also know that these two segments are equal to each other and to the orange ones, right? Because they're all radii. So now we see these two triangles are congruent by side angle side. Okay, so we have that the triangles are congruent by side angle side. And what does this do for us? Okay, so this gets us that these chords are equal here. Okay, so now we're noticing that this segment would have to be equal to this segment. So if we've got the same central angle, then the chords, so what we're ending up proving here is then that the chords are equal. So central angles, if central angles are equal, then the chords are equal. And so chords are equal or congruent from equal central angles. Versus in this last activity, they gave us congruent chords, gave us equal central angles. Now we know if the central angles are equal, the chords also have to be equal. And so that's kind of the difference between these two diagrams. Here they're giving you equal chords, and then you're proving that these angles were equal. Okay, so congruent chords proved that the central angles were equal. And then here, congruent central angles, okay, ends up forcing these chords to be equal. So either way, equal chords, equal angles, okay, they force each other. All right, so let's take a look at this. So decide, okay, just take a couple minutes to look at this picture. So figure out how many chords are drawn in the picture. So how many can you see? And can you name them all? And then is the orange angle CBA, a central angle? And what are the arc and angle measures can you find? So take a few minutes, pause the video, try to see that, and then come back to the video. All right, so a couple chords you would hopefully see. So DC is a chord. Okay, it goes edge to edge because C and D are both on the edge of the circle. It is also a diameter. Okay, so we have CD as one of our chords, or DC, whichever way. B to C would be a chord. B and C are both on the edge. And then ED is also a chord. Is angle CBA a central angle? So is angle CBA a central angle? And the answer to that would be no, because the vertex would need to be A. So the vertex, which is B, is not the center, or is not on the center. And then what are some arc measures that we can find? So we see that this is a 50-degree angle. So this would be 50 as well. We also see a congruent chord here and here. So congruent chord means equal arcs. So equal arc measures and an equal angle measure. So those central angles are the same. We know this diameter cuts it in 180 degrees. So then we would also know this side is 180. We already have 100 of it used up, so this piece must be 80. And therefore this blue arc would be 80. And this arc from C to D over here would also be 180. All right, so lesson summary, you can highlight a few things in here. We learned a few definitions. So we learned what a chord is, that it's a line segment whose endpoints are on the circle. I also added in here that it could be a diameter, but it doesn't have to be. Okay, so you do not have to have it be a diameter, can be though, if it goes through the center. A central angle is in a circle, okay, the angle whose vertex is at the center. So I've highlighted that green down here as well. So the vertex has to be the center. And I also added in that it's equal to the arc measure. Okay, so this angle measure here is equal to this. Okay, so the angle measure and the arc measure are the same. And the arc is just a portion of the circle between 2 points. So the just chunk between E and D here, that's an arc. E and C would be an arc. B and D, okay, all the way around. And in this one specifically, remember that we've got a 180-degree angle here. This part is listed as 90. And then these two are listed as equal. So these two total 90. And then divided by 2, each one of these would be 45. All right, so hopefully you know after watching this video what chords, arcs, and central angles are. You can check your understanding of this lesson by working on the practice problems for lesson 1. And if you need help with those, you can watch the video of me working through the solutions to each of those problems as well. And then here's your cool down. So check if you can do this. Now, can you draw a chord? Label it AB. That is not a diameter. Can you mark points C and D such that the arc from C to D measures about 120 degrees? So just estimate an arc measure about 120 degrees. And then draw a central angle that has a measure of about 45 degrees. And name that EOF. So go ahead, try to draw those onto this circle. If you're struggling, be sure you reach out to your teacher.